Let's solve the questions. Question 1. A, B, C, and D are points on the circumference of a circle. Angle ABD is 54 degrees. Angle BAC is 28 degrees. Find the size of angle ACD. Angle ACD is in the same segment as angle ABD. So this angle and this angle, they are in the same segment. So they are equal. So angle ACD is 54 degrees. The reason is simple. Angles in the same segment are equal. Question 2. A, B, C, and D are points on the circumference of a circle. Center O. Angle AOC is equal to 168 degrees. Work out the size of angle ADC. This is angle ADC. This angle ADC is equal to half of this reflex angle here, which is angle AOC. So the reason is that the angle at the center is twice the one at the circumference, or the one at the circumference is half of the one at the center. That's the reason. So angle AOC is equal to 360 minus 168. So half of this will give us angle ADC. So this will be equal to half of 192, and that will be equal to 96 degrees. So angle ADC is equal to 96 degrees. There's another way we can do it. So let me call this method 2. So with this method, we are going to consider this and this cyclic quadrilaterals. So first of all, we find this angle here, which is angle ABC. So we know angle ADC plus angle ABC is equal to 180 degrees. Angle ADC adding to angle ABC, which is half of 168 degrees. Again, angle at the center is equal to twice the one at the circumference, or the one at the circumference is half of this. So angle ADC, half of 168 is 84. So angle ADC is equal to 180 degrees minus 84 degrees, and that will give us 96 degrees. Question number 3. A, B, and D are points on the circumference of a circle, center O. BOD is the diameter of the circle. BC and AC are tangents to the circle. Angle OCP equals 34 degrees. Work out the size of angle DOA. This angle here is what we are looking for. If we know this angle and this angle, we just have to subtract their sum from 180, because angle DOA and these two angles are angles on a straight line. Now OC bisects the angle here, so it means this angle here is also 34 degrees. So this angle and this angle, we can find them. Since this is a tangent, BC is a tangent to OB, therefore they meet at 90 degrees. Therefore, this and this should also be 90. So the angle COB is 90 minus 34, which is 56 degrees. So this one will be 56 degrees. So angle DOA is equal to 180 minus 56 plus 56. Angle DOA will be equal to 180 minus 112 degrees, and that will give us 68 degrees. You can also approach it differently like this. Since this is 34 degrees, this is also 34 degrees. Then this angle and this whole angle here should be equal to 180, because this is 90, this is also 90, and the sum of angles in the quadrilateral is 360 degrees. So if already we have two of them being 180, then the remaining two should also be 180 degrees. So this is 34, 34, 68. This one will be 180 minus 68, which is 112 degrees. So this angle, which is angle DOA, will be equal to 180 minus 112 degrees, and that will give us 68 degrees. Question number 4. B and C are points on a circle center O. A, B, and AC are tangents to the circle. Angle BOC is 130 degrees. Work out the size of angle BAO. So BAO is this angle here, and we know this line AO bisect this angle here. So just like we just saw, this angle over here and this whole angle should be equal to, their sum should be equal to 180 degrees. So angle BOC, which is 130 degrees, and this one here should be equal to 180. So it means angle BAO, which is half of angle BAC. So angle BAO equal half of angle BAC. Angle BAC. So it means angle BAO should be equal to half of, now BAC is equal to 180 minus 130. So that will give you 50. So half of 50 should be equal to 25 degrees. So angle BAO is 25 degrees. A and B are points on the circumference of a circle, center O. PA and PB are tangents to the circle. Angle APB is 86 degrees. Work out the size of angle X. We have to get this angle here. This angle will sum up with the 86 to give us 180 degrees. So we know that X and this angle here is also x, because the base angles of an isosceles triangle are the same. So x plus x, sum of angles in a triangle, x plus x plus this angle here, angle AOB. Angle AOB is supposed to be equal to 180 degrees. Then already we know that angle AOB is 180 minus 86. So 2x plus 180 minus 86 should be equal to 180. So it means that the 180 and the 180 will subtract to give us 0. So we'll have 2x to be equal to 180 minus 180. Then the 86 becomes positive. So 2x will be equal to 86. Dividing both sides by 2, you get x to be equal to 43. R and S are 2 points on a circle, center O. TS is a tangent to the circle. Angle RST is equal to x. Prove that angle ROS is equal to 2x. You must give reasons for each stage of your working. So let's see how we can do this. This one we can just extend this to meet this and this to meet this. So if that happens, then it means that angles in alternate segments are equal. So if angles in alternate segments are equal, then this angle over here is 2 times of this. So this x is equal to this x. And this line now, this arm here is sitting on chord SR. And it is at the circumference of the circle. Then also the angle at the center is 2 times of this angle. So angle ROS is equal to 2 times of x. Another way you can do it is that the angle over here is 90 minus x. So 90 minus x. So that angle will be equal to this one, also 90 minus x. Now if you add it to angle ROS, all should be equal to 180 degrees. So straight ahead, you see that 90 plus 90 is 180. Negative x minus x will be minus 2x, negative 2x. So we have angle ROS minus 2x equal 180 minus 180. So angle ROS will therefore be equal to 2x. In the diagram, O is the center of the circle, A and C are points on the circumference of the circle, BCO is a straight line, BA is a tangent to the circle. AB is 8 centimeters, OA is 6 centimeters. Explain why angle OAB is a right angle. So we can see the reason. Radius OA and tangent BA will always meet at right angles. Then we have to work out the length of BC. So length of BC. So we know that from Pythagoras theorem, BO squared is equal to OA squared, which is 6 squared, plus AB squared, which is 8 squared. Now 6 squared is 36 plus 64. So it means BO squared is equal to 100. So BO will be equal to square root of 100. BO is equal to 10. But we know that BO is made up of BC plus OC. And OC is a radius, which is also 6. So BC plus 6 is equal to 10. What number plus 6 will give you 10? So BC is equal to 4, because 4 plus 10, 4 plus 6 will give you 10. A, B, C, and D are points on the circle center O. BC equal to CD. Then angle BCD is 130 degrees. Write down the size of angle BAD. Give reason for your answer. So angle BAD, this angle here, we know that that angle and this angle will be equal to 180 when we add them together, because they are cyclic quadrilateral. So angle BAD, so you can write that reason. Angle BAD, when you add it to angle 130 degrees, which is angle BCD, you should get 180 degrees. So angle BAD should be equal to 180 minus 130. So angle BAD is equal to 50 degrees. 50 degrees. So we can include the reason cyclic quadrilateral, opposite of angles of cyclic quadrilateral. Work out the size of angle ODC. So this angle ODC that we are looking for, we can connect a line from B to D, that is called BD. That's called divide angle ODC into two parts. So angle ODC that we are looking for, now this will be x degrees. This will also be x, because BC is equal to DC. Now if you write this to be y, then this will also be y, because the radii are also having the same length. So it means angle ODC is equal to x plus y. We can find this angle here, which is 2 times of this angle that we found already, which is 50 degrees. So it means that this angle here is 100 degrees. So right straight ahead, we can write equations. So this angle here, 100 degrees, plus this angle here, which is x plus y, plus this angle here, which is another x plus y, plus this 130 degrees should be equal to 360 degrees. So 100 plus 130 will be equal to 230. X plus y will be 2 times of x plus y is equal to 360 minus 230. So that will give you 130 again. So 130 here is equal to 2 into bracket x plus y. So dividing both sides by 2, we get x plus y equal 65 degrees. So x plus y equals 65 degrees. So it means angle ODC is equal to 65 degrees. In the diagram, A, B, C, and D are points on the circumference of a circle center O. Angle BAD is 70 degrees, angle BOD is X degrees, angle BCD is Y degrees. Work out the value of X. So we know that X is equal to 2 times of the angle at the circumference because X is at the center. So X will be equal to 140 degrees. Then Y. So the reason here is that the angle at the center is twice the angle at the circumference. Then also Y plus 70 degrees will be equal to 180 degrees. Opposite angles of a cyclic quadrilateral add up to 180. So Y equal 180 minus 70, and that will give us 110 degrees. The diagram shows a circle center O, A, B, and C are points on the circumference. DCO is a straight line. DA is a tangent to the circle. Angle ADO is 36 degrees. And then we have to work out the size of angle AOD. So this angle here. So angle AOD plus 36 degrees plus this angle which is 90 degrees is supposed to be equal to 180 degrees. So angle AOD is equal to 180 minus 90 minus 36 degrees. So that will give us 90 minus 36, which is 54 degrees. 54 degrees. So straight ahead, you should know that this and this should give you 90 degrees. So you can use that fact to get your correct answer. So that is angle AOD. We are asked to work out the size of angle ABC. Angle ABC, this angle here. So that angle is 2 times of the angle. The angle at the center is 2 times of this, or this angle is half of this angle. So angle ABC is half of angle AOD. So this is equal to half of angle AOD, which is half of 54 degrees, and that will be equal to 27 degrees. So you can give the reasons. Angle at the center is twice the one at the circumference, or angle at the circumference is twice the one at the center. B, D, and E are points on the circle center O. A, B, C is a tangent to the circle. B is a diameter of the circle. Angle DBE is equal to 35 degrees. Find the size of angle ABD. Angle ABD. So this angle here is what we are looking for. So remember that angle ABD plus 35 degrees must be equal to 90 degrees because the tangent will meet the radius at 90 degrees. So angle ABD should be equal to 90 minus 35, and that will give you 55, right? Yeah, 55 degrees. Then we are also asked to give reason. I know you can give that reason. The angle between the tangent and the radius is 90 degrees. Find the size of angle DEB. So angle DEB, so this angle here will be equal to this angle. Alternate angles in alternate segments are equal. So angle DEB is also equal to 55 degrees. This is also equal to 55 degrees. So angles in alternate segments are equal. You can also use the fact that this is equal to 90 degrees. So if you add these and these, you should get 90. P, Q, and T are points on the circumference of a circle center O. The line ATB is the tangent at T to the circle. PT equal TQ and angle ATP is 58 degrees. Calculate the size of angle OTQ. OTQ, this angle here is what we are looking for. And we already know that this whole angle is 90 degrees. So if we know this small angle here, we can subtract it from 90 degrees to get what we are looking for. And already we know that this angle is angle in alternate segment to this. So if you can find this angle, then why not? We'll be able to find that value. Then we also know that this angle is angle in alternate segment to this. So this is also 58 degrees. So since this is 58, we can find the sum of these two angles, this and this. So let me call this A, and this will also be A. So A plus A plus 58 should be equal to 180 degrees. Now, the reason why this is A and this is also A is that they are the base angle of isosceles triangle PQT. So 2A will be equal to 180 minus 58. So 2A equal 122. So A will be equal to 122 divided by 2, which is 61 degrees. So since this one is 61 degrees, we can find angle OTQ to be equal to 90 minus 61 degrees. And that will be equal to 29. Yeah, because 29 plus 61 will give you 90. Question number 13. D, E, and F are points on the circumference of a circle center O. Angle DOF is 130 degrees. Work out the size of angle DEF. So this angle here, we know that angle DEF is equal to half of angle DOF, half of 130, and that will be equal to 65 degrees. We know the reason is the angle at the center is twice the one at the circumference. The angle at the circumference is half of the one at the center. In a diagram, A, B, and C are points on the circumference of a circle center O. Angle ABC is 85. Work out the size of angle marked X. So angle X will be equal to 2 times of 85 degrees. The angle at the center is twice the one on the circumference. So this will be 170 degrees. X equal 170 degrees. Number 14. S and T are points on the circumference of a circle center O. PT is a tangent to the circle. SOP is a straight line. Angle OPT is 32 degrees. We have to work out the size of angle marked X. So this angle. So we start from here, from triangle OTP. We know that this angle here is 90 because it's a tangent, PT is a tangent, and OT is a radius. If that is the case, then we can find the value of this angle. That angle must be equal to 90 minus 32. So 90 minus 32, what will be the answer? So that will be 8 here, 58, 58. So if that is 58 degrees, then we can use the external angle property, external angle theorem. So angle OPT, angle X plus this angle should be equal to, so this angle here is X, is also X. So the external angles of a triangle, the two opposite external angle, the external angle 58 is equal to the sum of the two opposite interior angles. So the remote opposite interior angles are X plus X. So 2X will be equal to 58, and 58 divided by 2 is 29. So X equals 29 degrees.